Okay, so something weird went on with the WebEx and it made my computer freeze and then it made my computer crash and then it wouldn't boot up again and I got kind of worried about my computer anyway. So I wasn't able to go over our last three objectives to do with polar stuff. So I'm back in business here and I'm going to just make the video here. So the first objective is to be able to sketch the curve given a polar equation, and we're first going to do it by sketching r as a function of theta in the Cartesian, and then we will put that over on the polar. So looking here, I see it's 2 theta, so cosine's period is normally 2 pi, but it's divided by what's in front. So the period's going to be pi. So I'm going to go 1, 2, 3. The fourth one's going to be pi, so the middle's pi over 2, and this one's pi over 4, and this one's 3 pi over 4. I see the amplitude is 3, so I'm going to go up 1, 2, 3, and down 1, 2, 3. Now I'm going to go ahead and put this on. Cosine of 0 starts at its max, then it's going to cross, then min, then cross, then back to a max. So there is my graph. Now I'm going to go put that over on the polar. So I see at 0 I'm out 3. So I start at the pole and I go out 3. And then by the time I get to pi fourths, I'm down to 0. So as I'm looking here, pi fourths is right here, and I'm curving out and I'm heading towards 0 as I get to pi fourths. Then from pi fourths to pi halves here, I'm going negative. So by the time I get here to pi halves, I need to be at -3, which is back through the pole the other way. 1, 2, 3. So I'm moving through these angles and I'm doing negative here, increasing until I get to -3 there. And then as I look to see what happens next, I see that from pi halves, I'm still doing negative angles, but by the time I get to 3 pi fourths, I'm back to 0. So 3 pi fourths is over here. I'm doing negative angles in here, which are down here, and I'm curving back to the pole. Okay, then looking at this next piece from 3 pi fourths to pi, I increase till I get to 3. So by the time I get to pi, I'm at 3. So I'm increasing until I get to 3. Now, I've done one complete cycle, but I'm not done with this graph. So I'm going to need to draw some more on this graph. I'm going to do another cycle. So as I do that, I'm going to go 1, 2, 3. This one is 2 pi. So this one's 5 pi fourths, 6 pi fourths, which is 3 pi halves, and 7 pi fourths. And putting that graph then on there, we're going to cross, and then minimum, and then cross, and then maximum. So let's go ahead and put that on the picture. At pi, I'm out at 3, and by the time I get to 5 pi fourths, which is right here, I'm back to 0. Okay, then I see that I'm back to 0, and then I go negative to 3 pi halves, and I'm at -3. So 3 pi halves is down here, but I go back up 1, 2, 3 the other way because it's negative. So I increase and go up to 3. And then I'm going to go ahead and look at this next piece. I'm going to actually do this one in blue. So it stays negative, but it goes back to 0 by the time I get to 7 pi fourths. But I was doing negative numbers, so even though 7 pi fourths is here, as I'm moving around these, I'm back the other way, and I'm heading back towards the pole. And then the last piece of the graph is I'm going to go from 7 pi fourths, and by the time I get to 2 pi, I'm out again at 3. So there's my graph. Okay, with that graph, we need to be able to find regions inside of polar curves. And so let's go ahead and find the area enclosed by this polar curve. And I like to take, starting from 0 and looking at the, starting at the pole here and looking at this, I'm going to just take the first piece there that then follows symmetry. And the reason I like to do that is because this equation for area has a half in it, and if I'll use some symmetry, I can typically get rid of the fraction. So let's see, what is our formula for area enclosed in a polar curve? It is 1/2, and then between the two angles that you have, and then you take your function of theta, no derivative, just function of theta squared d theta. So here's our function of theta. So our area is going to be 1/2, and I'm going to go between 0 and pi fourths because that's that piece that I shaded in. Now there are 8 of those, so I'm going to times by 8 and see I can get rid of that fraction. Now I need the function of theta squared. So here's my function of theta. I'm going to square it and I'll get 9 cosine squared 2 theta d theta. So if I can evaluate this integral, I will have the area enclosed by this curve. Okay, so a couple things going on here. We have to remember from past stuff how to handle a cosine squared function when I'm trying to integrate, and that is using a half angle formula. So let's get the constants out of the way here. So that's going to become a 4 and the 9 is going to join it. So I'm going to have 36 and I'm going to integrate from 0 to pi over 4. But I'm going to replace the cosine squared with 1/2. 1 plus, cosine is plus. Cosine, it's normally 2 theta, but it already was a 2 theta, so it's going to be 4 theta, d theta. Okay, let's go ahead and move the half out in front as well. And so I can get rid of that. So it looks like I'm going to have out in front 18. And then doing the integral, that's going to be theta plus, this is going to become a sine 4 theta, but the chain rule would have generated a 4, so I need a 1/4. And I'm going to evaluate that from 0 to pi over 4. So let's go ahead and put in pi fourths. So we got 18 pi fourths. And when you put pi fourths in times 4, it's the sine of pi, which is 0. And then the lower limit is 0 and 0. So our final answer is going to be 18 pi fourths, which reduces down to 9 pi over 2. So the area enclosed by this polar curve is 9 pi halves. Okay, the last and probably kind of hardest thing to do would be to find the slope of a tangent to a polar curve. And so let's go ahead and look at that, and I'm going to go on to the next screen to do that. Maybe I am. Okay, so here let's go ahead and find the tangent. And actually let's go back first, and we're going to find the tangent at pi. Let's see if I can get this to right. Okay, we're going to find the tangent at pi over 6. So pi sixths is right in here, and so there's going to be a tangent line right here to the curve at pi 6. So it looks like it's going to be some kind of a positive slope, but not too steep. So let's go ahead and find that on this next screen then. Okay, so we're looking to find it at pi over 6. Okay, so the way we find a tangent is we need dy dx. So if you remember in polar curves, x is r cosine theta and y is r sine theta. And so if I want dy dx, I'm going to take dy d theta over dx d theta. Okay, so dy d theta right here is going to be, it's a product because r is a function of theta. So it's going to be first times the derivative of the second plus the second times the derivative of the first. And I'm just going to keep the r in the same place. So there's the derivative of r is just r prime and then sine theta. And that's going to be over dx d theta. Well, here's x, so dx d theta would be first times the derivative of the second, which is negative sine, plus the second, which is cosine, times the derivative of the first, which is r prime. So there is my formula for finding the tangent, which is the slope of the tangent, which is dy dx. So we're after the slope of the tangent there. Okay, so r is right here. Let's find r prime, so when we need it. The derivative of 3 cosine 2 theta is going to be 3 sine 2 theta with the negative and then times the derivative of 2 theta, so times 2. So it looks like it's going to be negative 6 sine 2 theta. All right, so let's go ahead and plug in all of those pieces then. So we need r, which is 3 cosine 2, and I'm going to go ahead and plug in the theta, which is pi 6. And then I need cosine theta, which was pi 6. And then plus, and I'm not going to have enough room. Okay, I'm going to start it again, and I'm going to start it down below so I've got enough room. So r was 3 cosine 2, and our theta is pi 6. and then cosine, so that was the r, but now I got cosine theta, and theta was pi sixths. Okay, plus r prime was right here, so it's actually going to be a minus 6 sine 2, and our theta is pi sixths, and then I've got sine theta, so sine pi sixths. Okay, and that's over negative r. Okay, so r was right here, and so it's going to be negative 3 cosine 2, put in pi 6, and then it's going to be sine theta, so sine pi 6, and then plus r prime, but it was negative on r prime, so negative 6 sine 2, and put in theta, pi 6, and then cosine of theta, so cosine pi over 6. Okay, so now we've just got to simplify that, and we're going to need two values, pi sixths is square root 3 over 2 and 1/2 for sine and cosine, and pi thirds is the other way around, it's 1/2 and square root 3 over 2. So if I put in those values, this one is pi thirds, and so the cosine is 1/2, so I've got 3 times 1/2 times cosine of pi 6, that's square root 3 over 2, and then minus 6 sine of pi thirds, that's square root 3 over 2, and then I need sine of pi 6, that's 1/2, and then that's going to be over negative 3 cosine of pi thirds, so the cosine of pi thirds is going to be 1/2, and the sine of pi sixths is also going to be 1/2, and then minus 6 times sine of pi third is square root 3 over 2, and then cosine of pi sixths is also square root 3 over 2. Oh, and I'm off the screen. I'm sorry, I said it, but it went outside of the recording area, and I hadn't realized that, trying to fit all of this on. So bottom line, plug in the values for the trig functions and combine those and simplify, and you should be able to get, when you simplify it, square root 3 over 7, which is the slope of the tangent line at pi 6. So sorry, I kind of ran off the screen with those. This one here was negative 6. This was square root 3 over 2. And this one was 1/2. And down in the denominator, it was negative 6 and square root 3 over 2 and another square root 3 over 2. And then I just multiplied all of those things and simplified it, and I got square root 3 over 7. Okay, I'm going to go ahead and post this, and good luck on the midterm. I didn't get a chance to ask if you had any questions because everything froze, so please feel free to email me, send me a message if you have any questions on anything, and I want you to do well, so study hard for the midterm and good luck on it.